Okay, so this is chapter 13, the Inequalities chapter for my book, Overcoming Digital SAT Math. So before we get started, just remember if you already have a copy of this, make sure to attempt it on your own and attempt corrections on your own before referencing this video for explanations on anything you can't figure out how to correct on your own to get the best results. And also, I'm going to put in the description of this video a link to the ACT version of this chapter if you want to see like a lesson and like some other example problems as well before you start on these. So let's start with number 1 right here. And then just also as a quick reminder, remember that basically inequalities are almost identical to equations in a way, like solving equations. It's just that if you divide or multiply by a negative value, you have to flip the symbol, the inequality symbol. So like for instance, if I have negative 3x is greater than 15, I just have to remember because I'm dividing each side by negative 3 that I have to flip it over to become less than over here. Thank you guys for the likes. Okay, so let's start with number 1. It says a tutoring company offers 2 types of courses, a budget course and a premium course. Each budget course is sold for $150 and each premium course is sold for $300. If the company sells a total of N courses and earns more than $45,000, which of the following inequalities best represents the number of budget courses B and premium courses P that the company must sell? So I'm going to put a little like B by the 150 because that's the price per like each budget course, and then a P by the 300 just to remember that. So if we are trying to figure out how much how many budget courses are being sold in order to earn more than 45,000, we need, and premium courses, as well, we have to do $150 times each of the budget courses that the company's going to sell, plus 300 times P, the number of premium courses that are going to be sold. And then when we add those up, we need to know that that's going to be more than or greater than $45,000. So right away, let's see if there's anything I can cross out from that. Well, automatically I can cross out C and D because those have the inequality symbol going the wrong way. So now let's see what the second portion is. So the second portion is almost identical. It's like we have the number of budget courses plus number of premium courses equals the N total number of courses, but it's this part that's a little bit different. So let's see, this says the number of budget courses has to be greater than or equal to 0, and the number of premium courses has to be less than or equal to N. Yes, that tracks. So then over here, we have that the number of budget courses has to be greater than or equal to 0, but then also the number of premium courses has to be greater than or equal to 0. So that's where this kind of falls apart, because we don't know that we don't necessarily know that they need to sell more premium courses than the budget courses. So that's where that ends up being wrong. So it would have to be A only. So then let's go to number 2. So which of the following points satisfies the system of inequalities above? So this, all you have to do, like remember, these points are just always going to be X comma Y. Like that's your X value, that's your Y value. So you can technically just plug this in, especially with like 1s and 0s. It's real easy to do in your head. You can just plug in like 1 for X and 2 for Y and see if that works. So let's do that to check out A. So for A, I'm going to plug in 1 for my X, so then 3 times 1 is just 3, minus 2 for my Y. Is that going to be less than 1? No, it's equal to 1. So automatically, that one is not it. So now let's try B. So we're going to make the X value 2 and the Y value 0. And let's see if that works. So 3 times 2 minus 0 has to be less than 1. That does not work because that would just be 6 is less than 1. Nope. So then Now let's try for our x value 0 and our y value 3. So 3 times 0 for x is going to be 0 minus 3 for my y value. And we're going to say that that's less than 1. Yes, negative 3 is less than 1. But remember, it has to work for both. So we have to check it in the second one as well. So my x is 0. 2 times 0 is 0. Plus 3 times 0 is just going to be 0 as well. And then that has to be greater than, I plugged in 0 twice. I meant to say 3 times 3. I was like, why did I do 0 twice? 3 times 3, which is going to be just 9, because that 3 is the y right there. And we're going to say that has to be greater than 6. And yes, 9 is greater than or equal to 6, so that works as well. So the answer is C. Okay. So is there one down here? No, it's up here. Let me just erase this so it doesn't look all messy. Okay, so for number 3, it says a publishing company needs to print at least 1,500 books for an upcoming event. The books will be made up of hardcover copies, which will cost $15 each, and paperback copies, which will cost $8 each. Their budget for printing the books is no more than $18,000. They must print at least 700 hardcover copies and at least 500 paperback copies. Which of the following systems of inequalities represents the conditions described if H is the number of hardcover books and P is the number of paperback books? So first of all, I just want to mention also that it's very unlikely on the digital SAT that you're going to get like these types of very long word problems, because one of the main changes is that they shortened it. I just thought it would be a good idea to keep these in this version of the book just as like an extra challenge, but I just wanted to kind of point that out. But anyways, so hardcover copies is going to be represented by H. Where's my pen? By H, and then paperback is P. So we know that there has to be at least 1,500 books in total. So if we're finding the total number of books, that would be H plus P, the hardcover copies plus the paperback copies. And that has to be at least 1,500 total books. So it could be 1,500 or it could be more than that. Like think of it in a real life scenario. If it's at least that many books, it could be like 1,501, 1,502, like is what all of this H plus P can be. So that's kind of how you can figure out if you haven't memorized like the wording of which way the inequality symbol goes, you can kind of just think the real life scenario. So H plus P has to be greater than or equal to 1,500. So that means automatically I can cross out A, and let's see if there's another one. And then I can also cross out D right over here. So now let's do the rest of the problem. So the 18,000, what is that? Their budget? There's a budget for printing books that is no more than $18,000. So remember, each of the hardcovers costs $15. So if I want to know how much they're going to be spending on the hardcover copies, it's going to be $15 times each number of hardcover copies. And then I need to add that to how much they're spending on the paperback copies, which would be $8 for each of the P paperback copies. And then their budget, like when we total this all up, when we add it up, they can't be spending any more than $18,000. So they can be spending $18,000, they can be spending $17,000. Like it has to just be $18,000 or less, basically. So when we add this up, it has to be less than or equal to $18,000. So let's see, that will already tell us what the answer is, because B and C, they're opposites. So it's just going to be answer choice B. So let's go to number 4 now. So for number 4, it says Linda has saved D dollars for a new phone. The actual cost of the phone, C, is within $20 inclusive of Linda's savings. So like it includes $20 as well. Which of the following inequalities represents the relationship between Linda's savings and the actual cost of the phone? Okay, so cost of the phone, the actual cost of the phone is C, is within $20 of Linda's savings. What are we doing the savings? Oh, savings is D. Okay, so it's going to be within $20. So then C is the cost of the phone, and then it can be $20 less or $20 more than what she saved, basically. So it can be D is the saved amount of dollars, so it could be 20 less than that, or it could be 20 more than that. And then C just has to be equal to that or like in between that, basically, the cost of the phone. So the answer would be C. Okay, thank you guys for liking the live. So let's go to number 5. Which of the following is a solution to the given system of inequalities? So this is similar to like the earlier problem where, remember, it's just all your points are just x comma y. So if it works, if the point is a solution to the system, it means it works for both of the inequalities. So let's try it one by one. So let's try with 6 comma 4. So 6 is going to be your x and 4 is going to be your y. So 4 for y, 6 for x. 4 is less than 6, but let's go to the next part to make sure that this is also true. So this part says that the x value has to be greater than 9. Well, the x value is 6. Is that greater than 9? No. So it can't be answer choice A. And also I'm going through this one by one, but obviously like one of the easier ways to just do this would be to start with just looking at the x values to make sure they're greater than 9, like more efficient way, because you could have just looked at the second one and said, okay, 6 is definitely not greater than 9, 9 is not greater than 9, so then you can cross out B, 10 is greater than 9, 11 is greater than 9, so then you can just kind of like start with C and D more efficiently. But I'm trying to go through like the explanation of a whole point before I continue on. So now what we're going to do is we're going to say, okay, it's between C and D. So now let's plug in. So for C, our y value is going to be 8. And then our x value is going to be 10. 8 is in fact less than 10. So let's try it for the other one. Well, we already did the other one, but I'll just show you anyway. 10 is greater than 9. Yes, that checks out. So it's that one. And then let's just show specifically why it can't be answer choice D. So with D, let's do 12 is our y and 11 is our x. Well, 12 cannot be less than 11. So like you disprove it that way if you need to. So let's continue. So for number 6, we have this. What is the least possible value of 4p plus 2? So first, let's solve for p. So I'm going to add 3 to each side. So then I'm going to get 4p is greater than or equal to 5. Then I'm going to divide by 4 on each side. So then I'm going to get p is greater than or equal to 5/4. So basically, p can be equal to 5/4 or it can be a value that's greater than 5/4. And I want the least possible value. So like the lowest possible value I can get for 4 times p plus 2. Well, to get the lowest thing possible for 4p plus 2, I have to be using the lowest p possible. The lowest p possible would be that it's equal to 5/4, because after that it just goes up. So I would just have to do 4 times 5/4 plus 2, cross cancel those out to 1. It's just 5 plus 2 is 7. So the answer would be C. Thank you guys for the likes. Okay, so let's keep on going. So for number 7, if 5x is less than 7, then you're basically just solving for x. So this is pretty easy. You just have to divide by 5 on each side and you would get this. X is less than 7/5. And oh my god, the thing where it flips numbers in my brain is doing, this is like tripping me out. So then it's going to be D. Okay. So let's erase that so it's nice and neat. Okay, so then let's go to number 8. M and N are positive numbers. If M is equal to N and O is less than P, then, okay, so M and N are, for these types of problems, one thing that you can do, instead of like working with hypotheticals, if you're like bad at keeping track of that in your head, is you can pretend that like you know what the numbers M and N are, and like what O and P are, but you're just like, you're picking potential numbers that work in the scenario. So like they told you m and n are positive. So like you could say, okay, I'm going to say that m is 3 and n is 3 because they're the same thing. Like m and n are equal to each other. So that could be m, that could be n. And then we're going to say that O has to be less than P. Now here's where you have to like be careful with plugging in numbers, because sometimes it'll work like in multiple, like it'll give you multiple different things for different scenarios, but it's like a good shortcut to kind of eliminate things sometimes. But if we say O is less than P, we could say that like O is maybe, I don't know, 2, and then that P will be 4. And then, so now what we're going to do is we're going to say, okay, I'm going to plug it into this situation. So I'm going to say, okay, if I have O is 2, 3 plus 2, is that going to be less than 3 plus 4 for P? And yes, it is. Now, I would encourage you to kind of like plug in for each of them just to make absolutely certain that it eliminates all of them. Because again, like I said, sometimes this trick for plugging in does not work with all numbers that you're going to pick. So let's see if that happens here or if we get lucky. So 3 plus 2 is greater than, n is going to be 3 plus 4. So 5 is not greater than 7, so no. And then m is 3. Oops. 3 minus 2 for O is greater than 3 minus 4. So 1 is greater, you see how it happens there? 1 is greater than -1, which is a thing. So it could be that one as well so far. And then we have m is 3 plus 2 for O has to equal 3 for N and 4 for P. Well, that's not true. So like you can use it to help you narrow down and eliminate answers is kind of what I'm saying. Sorry. Or you can help it to, you can use it to help you solve, but you're going to have to probably pick a bunch of different like values that have different characteristics. For instance, they didn't tell you that, I keep wanting to say 0, that O and P, they didn't say like one's negative, one's positive. Like they didn't tell you it had to be positive or anything like they did with M and N. So maybe this time I'll pick like a negative value for one or both of them. So why don't I try, I'll do -4 is less than, and then I would do like, I don't know, 1 for P. So then let me try that for each of these. So then I would do, okay, 3 plus -4 is less than 3 plus 1. Yeah, 1 is P. So then I would have -1 is less than 4. That checks out. So let me try it now for C, the other remaining one. So then I would try, okay, 3 minus -4 is greater than 3 minus 1. You see, and it keeps working. Oh my God, this is so annoying. This is why I kind of hate showing it this way, because you have to like keep trying over and over and over again. It's so annoying. Oh, let's try it with 2 negatives now. Let's say that this is going to be -1. And you see how I'm trying like different characteristics of different numbers. I just really want to include like an example with this so that people see what I'm talking about when I say plug in. So 3 plus -4 for O is less than 3 plus -1. So then that would be -1 is less than 2. Yes, that checks out. Now let's try it for C. So then it would be 3 minus -4 is greater than 3 minus -1. That kind of got cut off. So then that would be plus, this is plus. Oh my God, I hate this. I hate when you have to keep picking the numbers. Okay, let's try something else. Well, now let's just try reasoning, because I'm not going to pick numbers all day. It's annoying. Okay, so we know that m and n are positive numbers that are equal to each other, and that O has to be less than P, but we don't know that if these are like positive or negatives. So it probably has something with like these when it narrows it down to like do it 0 maybe sometimes. So let's see. So if M and N are the same thing, and then O has to be less than P, then it would have to be A, because you could say, okay, I'm going to actually add these up. Like M is the same thing as N, right? So technically these are equal right now. But then if I add a lower value, like O is lower than P, and I add a lower value on this side, and I add a higher value on this side, then this overall sum is going to be lower. So like that's an example of like how logic is probably like way more efficient, but a lot of people can't reason like that and they have to use the plug-in method. So like you could keep plugging in technically is what my point was with that. So then let's go to number 9. So for number 9, given that k is an odd integer and we have this, what is the least possible value of k? So the lowest, the least possible thing k could be. And we know that k is an odd integer. So let's start by doing distributive property, -5 times each of these terms in parentheses. So that's going to be -5k, and -5 times -8 is going to be plus 40. And then that's going to be less than, now do distributive property with the 4 in these terms. So 4 times k is 4k. Thank you guys for the likes. And 4 times -3 is -12. Okay, so again, inequalities, very similar to solving equations. It's basically the same thing unless you divide or multiply by a negative. So let's go ahead and add 12 to each side. So then I'm going to have -5k plus 52 is less than 4k. And then I'm going to add 5k to each side. So then I'm going to get 52 is less than 9k. So then I'm going to say, okay, well, I'm going to divide by 9 to get k completely by itself. So I have 52 over 9, not equal to, whoops, is less than k. And I don't have to flip the inequality or anything because I'm not dividing or multiplying by a negative. So basically k has to be an odd integer that's greater than 52 over 9. So 52 over 9 is a value that's between, because 9 times 6 is going to be 54. So it has to be a little bit less than 6, like between 5 and 6. So this is a number between 5 and 6, basically. And we know that k has to be greater than that, and it's an odd integer. So then it could technically be 7 as the least possible value of k. Like it could be 7, it could be 9, but like they're asking for the least possible value. So we're going to pick 7 here. So let's go to number 10. So let me just get water really quick. Okay, so for number 10, which of the following is a solution to the inequality? Again, it's very similar to, solving equations. So I'm going to start by, I'll just add 15 to each side. So you could add the 5 also to each side, but I'm just choosing to do adding 15. So -2x, and then -5 plus 15 is going to be plus 10. And then it cancels out on this side when I add 15 to each side. So then now I'm going to get the x's together. So I'm going to add 2x to each side. So then I'm going to get 10 is greater than 5x. Now I'm going to divide by 5 on each side. So I'm going to get that x has to be less than 2. So which of these could potentially be x? Could potentially be the solution to the inequality? Well, the only value that happens to be less than 2 would be a. So let's keep going to number 11. So for number 11, again, very similar to solving equations. So let's start by just adding 15 to each side. So then it's going to be 2/3 x plus 10 is greater than 1/3 x. Now I'm going to subtract 2/3 x from each side, so then we get 10 is greater than 1/3 x minus 2/3 x is going to be negative 1/3 x. Now here's where it's different than solving like with an equal sign. Hold on, I think I have a little dot right there. Okay. When we want to get x by itself here, we're going to have to divide by negative 1/3. When you divide or multiply by a negative with an inequality, you have to flip the inequality symbol. So now the symbol is going to go this way. So we're going to have x is now greater than 10, and then divided by negative 1/3. Remember, keep, change, flip. We're going to keep 10 as 10 over 1, change the division to multiplication, and then flip this to be negative 3 over 1. So then this is going to be negative 30. X has to be greater than negative 30, basically. So the answer is going to be D. Surely B and D are correct. D is correct. D is the correct answer because that's a negative. So then let's go to number 12. But B is also true. Which of the you see, I misworded this question. I should have said, which of the following, I think I was trying to say, like, which one is, like, all the solutions to this, encompasses all the solutions. I just worded it wrong. So thank you for catching that. I need to fix that. Okay, so then let's go to number 12. If point D lies between E and F on line segment EF, so let's draw this. We have line segment EF, and then we're going to have point D lies in between. I know it looks like a midpoint. It doesn't necessarily have to be a midpoint, though. I'm just kind of drawing it like that. And then, so this is point E, this is point F. Which of the following is always going to be true? Well, let's look at our options. So let me just look really quick. Well, the whole entire line segment is equal to, is like EF, right? And that line segment is made up of this portion and this portion. So no matter what, if we just add up the parts, each of those two parts together, we get the whole line segment. So it would have to be D. Okay, let's go to number 13. Which of the following systems of inequalities could be the one graphed above? So, for this one, like you see where it's darker right here, all over here, that's the overlap. That's where the solution is to the systems. So what you could do is just, and what I think is easiest for most students, is just pick a point that's part of this, like the extra dark shaded part, the solution set, and see, okay, what does that work with? So let's try just like, let's do 0, 5 right there. And then let's see, okay, what fits if we put in x as 0 and y as 5, what's going to fit this situation? So let's do it for A right here. So is 5 greater than 4? Yes. And then 5 is our y. Is 5 greater than 0? Yes. So those both fit, so it could potentially be A. And then for B, it would be our y is 5. Is 5 less than 4? No. And same thing here. It's the same exact thing. Is 5 less than 4? No. But is 5 greater than 4? Yes. But then let's check the other one. Y is less than x, so our y for the point that we picked is going to be 5. Is that less than 0 for our x? No. So then it has to be A. Okay, so that was 13. So now let's go to number 14 right here. Thank you guys for sharing the live. So let's, oh, I don't like that this is carrying over. Hold on, I'm a little OCD. Okay. But actually, so then let's go to number 14. We're going to solve for x. So we're going to distribute we're going to distribute the 7 to each of these terms. So then it's going to be 10x, we just copy over. 7 times 2x is going to be 14x. And then 7 times 5 is going to be 35. Now let's get our x's together by subtracting 14x from each side. So then it's going to be negative 4x is less than 35. Now we're going to divide by negative 4. Remember, when you divide by a negative, you have to flip the inequality symbol the other way. So when I divide by negative 4, I'm going to get negative 35 over 4 right there. So then that would have to be, which one says that? A. Okay, and let's go to number 15. Whoops. There we go. Okay, number 15. If x is greater than 0 and y is greater than 0, which of the following is always true? Again, you can do that whole plug-in thing where you can say, okay, I'm going to pick, I don't know, like 2 and 3. That if these are both positive, like 2 times 3, I mean, you could I'm going to do it both ways. So you can say, okay, I'm going to pick 2 and for x and 3 for y. So then let's plug it in. 2 times 3, is that going to be less than 0? No, can't be A. 2 times 3, is that going to be greater than 0? Yes, so it could be B. 2 minus 3, is that going to be greater than 0? No, so it can't be C. And then for D, it's going to be 2 plus 3, is that less than 0? So this is one of the ones where you get lucky if you use like the plugging in formula, where it's just very easy to tell that it's going to be answer choice B. But like the faster way, like with logic, is just if I have 2 positive numbers and I multiply them, the answer is always going to be positive. So then it's just B. So then let's go to, whoops, okay, there we go. Number 16. So for number 16, we're going to, some people like to like keep it all together. I would recommend for most students that you kind of break this apart into 2 separate inequalities that you're doing, just so you don't get confused. So that's what I'm going to do. So I'm basically going to say, okay, this is going to be its own inequality, and this part's going to be its own inequality too. So let's start with this portion right here. I'm going to distribute the 3 to each of the terms in parentheses. So 3 times 4m is going to be 12m. And then 3 times negative 5 is negative 15. That's going to be less than or equal to 2 times each of the terms in parentheses. So 2 times 3 is 6. And then 2 times 3m is going to be 6m. And then now I just have to solve for m. So now I'm going to subtract 6m from each side. That's going to give me 6m minus 15 is less than or equal to 6. Then I'm going to add 15 each side. So then I'm going to get 6m is less than or equal to 21. And then I'm going to divide each side by 6. So then I'm going to get m has to be less than or equal to 21 over 6. So just from that part, technically just from that part, I think you can solve it because, yeah, because 6 goes into 21, like, you get a number between 3 and 4, because, like, 3 times 6 is 18, and then 4 times 6 is 24, so a number between 3 and 4, and m has to be less than or equal to a number, to that value that's between 3 and 4, so it can only be A. But you don't always get that lucky, so I'm going to show you how to solve the other portion. So basically it's saying this is between 3 and 4, m has to be less than or equal to that. If you wanted to solve or had to solve the other side, what you would do is you would say, okay, now I'm working with this portion, which we know when we distributed the 2 that we got this already, so that's just going to be 6 plus 6m is less than or equal to this portion right here. Let's distribute the 4, so then it's going to be 12 plus 12m. And then now let's solve, so subtract 6m from each side. We're going to get 6 is less than or equal to, that's going to be 12 plus 6m. And then now we're going to subtract 12 from each side, so that's going to be negative 6 is less than or equal to 6m. Whoopsies, that's supposed to be an m. I don't like how that looks. Okay, so now we're going to divide by 6 on each side. So, and this is important because this is a common mistake people make when I teach with them. What a lot of you guys do is you think that just because a negative's involved in the division or multiplication that you always need to flip the sign. That's not it. It's when you divide by a positive or a negative. And it became -6 for the person asking because I subtracted 12 from each side. So 6 minus 12 is -6. So now I'm going to divide by +6, but the inequality symbol stays the same because I'm not dividing or multiplying by negative. And then it's going to be -1 right there. So like that's how you could solve, and then you just know that m has to be greater than or equal to -1, but then it also has to be less than or equal to 21/6. So like if you had to solve the whole thing, that's what you would do. But for this problem, you don't necessarily have to. Let me get rid of that. Okay, so now with what? Okay, so now let's go to number 17. I love how you solve questions. Thank you. Okay, so number 17. Which of the following values is a solution to the inequality below? So again, treat it pretty much just like an equal sign unless you're dividing or multiplying by a negative. So let's multiply each side by the 3. So if I multiply each side by the 3, I'm going to get 27 because 9 times 3 is 27. And then 3 times -x is -3x. And that's going to be less than, if I multiply by 3 on this side, it's going to cancel out. So I just am left with the numerator. And then we're going to, well, you can do several different things. I'm just going to add 6x to each side. So I'm going to add 6x to each side. So then I get 27 plus 3x is less than -3. Now I'm going to subtract 27 from each side, so then I'm going to get 3x is less than -30, because -3 minus 27 is -30. Now I'm going to divide by 3 on each side, so then I'm going to get x is less than -10. So let's look at our values over here. Do we have any values that are less than -10? Yes, we do. The only option we have is D. Someone said that they didn't get number 16. So basically for number 16, you break it into 2 different equations if you wanted to solve the entire thing. But technically, you could just do this portion right here, and you already know the answer because there's only one option that fits what we got as the answer there. So I was saying, like, you don't have to do both sides in this particular instance, but I was showing you just an example of how to if your teacher or something required you to. Okay, so let me just get water really quick. Okay. So now let's go number 17B. No, it's not B because it has to be less than -10, not equal to -10. So the only number less than -10 would be -11. So let's go to number 18. So if x squared is less than 9, then, okay, so x squared has to be less than 9. So to get x by itself, you would have to take the square root. Now, but here's where it's kind of a little bit tricky with this problem and why I included it here. Remember that you can get 9 if you do -3 squared or if you do +3 squared. There's 2 different options that work to get you exactly 9. But remember, we want x squared to be less than 9. So in order for that to happen, that means that it's easier usually for people to start with like the positive one. So like that means that if we want to talk about like +3 being x, that the x value would have to be less than +3 in order for that to work, where x squared is less than 9. And then you have to think, okay, I also need to include a negative value, the -3 option. So then in order for x squared to be less than 9, that means that x has to be greater than -3. It can't be the one with the little line where it's also equal to, because it doesn't say less than or equal to. It's just saying less than, not equal to it. So then that would just be C. Yes, for the people that said C, you are correct. So let's go to, and sorry if I'm missing questions in the comments. Sometimes I get distracted by like doing the work, but at the end, I always leave time for questions. So let's now go to number 19. So number 19, solve for x here. So again, pretty similar to equations. We just have to divide by 0.05 to get x by itself. So we're going to say, okay, we have negative 0.3 divided by 0.05. And you have your calculator available to you on the exam, but just like right away, even before you punch it into your calculator, you know it has to be a negative value because a negative divided by a positive is negative. And then you also know that the inequality symbol doesn't change. So actually, you don't even technically need to plug this into a calculator at all. You can just say, oh, I know that the symbol like this doesn't change like direction because I didn't divide by a negative. So the only option it could be is C. So then let's go to number 20. So thank you guys for sharing and liking the live. So let's go to I'm on 20, yes. Okay, if 20k is less than 15, then solve for k. If necessary, round to the nearest hundredth. Okay, so you just have to get k by itself. So I have to just divide by 20 on each side. So it would just be 15 over 20. K is less than 15 over 20. And then let's divide by, well, technically, you could divide by the greatest common factor. There's different ways to do things. I just, in my head, what I do is I divide by the greatest common factor if I see that it's going to be something easy. Like in the options, like half of them are 0.75. So I would just go ahead and divide by the greatest common factor, and I would get 3, because the greatest common factor is 5 on top, 3/4, which most of you guys and like myself have memorized those basic fraction bar thingies that they taught you in like 4th or 5th grade, I think. And we know that like 3/4 is 0.75. So then it would be k is less than 0.75. But you could also technically, like, you didn't have to do that. You could have just said, oh, I know that the fraction bar is the same thing as division. So I could say that that's 15 divided by 20. And then you could have just solved it that way, or like in your calculator, because you have a calculator on this. Hope you're recording so that you post on your timeline, please. Yes, I am recording. This will go up on my YouTube tonight. So let's keep going to number 21. If n plus 3.2 is less than 1.9, then solve for n, if necessary, round to the nearest tenth. So again, just like with an equal sign, we're going to subtract 3.2 from each side to get n by itself. So I'm going to have n is less than 1.9 minus, that was a terrible 3. I write my 3 so bad on here. Minus 3.2. So obviously that's going to be a negative. For a lot of these, you don't even need to like actually do the calculations. So that's obviously going to be a negative because you're subtracting a larger value from a positive value. And then we know that the sign didn't change direction, so it has to be C. So now let's go to, can't wait to subscribe, I'm new here. Oh, and someone else asked a question. Well, I'm glad that you're enjoying it. So when will it be greater than? It would be greater than if, like, for instance, if this was negative n plus 3.2 is less than, like, if they had a negative in front of it, and then you did this, but then there was a negative right there, and you had to, like, divide by a negative, then the inequality symbol would change. That's when that would happen. Or, like, if it was already like that, like, maybe it started like this instead. So it just depends on the context. Okay, so number 22. So, Alex is trying to break the record for the largest bed built in Florida. In order to break this record, the perimeter of the bed needs to be at least 80 feet, and the area of the bed needs to be at least 400 square feet, given that the length of the bed is L meters and the width of the bed is W meters, which of the following best represents this context? Okay, so a bed is a rectangle, right? So we know that, what did they say? The perimeter of the bed needs to be, I always say, what do they say? I wrote this. The perimeter of the bed needs to be at least 80 feet. So perimeter, if we're talking about like a rectangle, like there is in a bed, and we have L for our length and W for our width, perimeter would just be adding all of these up, right? So if I'm adding these up, L plus L is just 2L, and W plus W is just I keep writing my numbers weird. And then W plus W is 2W. And then it has to be at least 80 feet when we add that up. So it could be 80 feet, it could be 81, 82. It just has to be at least that. So this has to be greater than or equal to 80. Now you'll notice there's nothing really that looks exactly like that for the one of the two inequalities. What you can do now is ask yourself, how can I manipulate this so that it looks like one of the answer choices? Well, there's a greatest common factor of 2 that you could take out. And then divide by that 2. On each side, it's canceling it out on the left, but on the right-hand side, you'll get 40. So now you have something that looks like only one of the answer choices, actually, A. So it has to be A. And then you can verify that the second one is correct as well. I'll just go through explaining that. Where it says that the area of the bed needs to be at least 400 square feet. Remember, area of a rectangle is just length times width. So length times width has to be at least 400 square feet. So this, when you multiply it, could be 400, it could be 401, it could be 402, all of that, which matches up with L times W is greater than or equal to 400. Siri, voice. I'm autistic, so, I mean, that tracks if you're calling me Siri, kind of. Okay. Please don't get offended and cancel me. Okay. So 23. Let's go and do that. Where's the graph? There it is. And, okay. Number 23. The shaded region represents all solutions to an inequality. Which of the following is a solution to the inequality graphed above in the XY plane? And then sometimes I add these bonus questions, so we'll do that after. So like all this gray area is basically like all of these points work. And also like the points on this line. If you have a solid line, then the solutions also include that line. If you have something like this where it's a dotted line, then the solutions on that dotted line don't, the points on the dotted line don't count as solutions, because it's saying like, it's like all the shaded part except it gets cut off at this dotted line. But if it's solid, it can include the points on that line. So we have these points, we just have to check if they're in the shaded part or on the line exactly. So we have 4, 0 would be 1, 2, 3, 4, 0s right there. That is not in the shaded portion. Then we have 0, 4. 0, 4 is right here on that line, so it counts. So it has to be B. But let's just prove why it's not C or D. So for C, it would be 5. And then -3 right here, that's not in the shaded region. And then we have 3, 5. So 3, 5 is right over here. That's not in the shaded region. So that's how you could disprove C and D. So thank you guys for liking and sharing the live. Let's go to number 24. Which of the following inequalities matches the graph? So this is like similar to this other question, except now it's an equation. And just like I was saying with like solving inequalities is very similar to equations, it's also very similar to like graphing equations. Basically, the only difference is the shading and like deciding if you need a dotted or a solid line. So, first of all, the easiest thing to do is we could automatically eliminate C right away, because you see how there's that little line underneath? Whenever you have this or this, like with the line underneath, that means that it has to be one of these solid lines, not a dotted line. So automatically that means we can eliminate C. And then we can say, okay, if I want to know like the exact graph of the line, like what this dotted line is, where this dotted line is, like where to plot it, it's the same exact thing as if you were trying to graph a linear function, where you find the slope and you do y equals mx plus b. That's the same exact thing, except you don't have an equal sign, basically. So we're going to follow the same steps as if we were graphing a linear equation, and we have those 2 points right there. So 2 points mean we can do slope formula to find the slope. So I'm going to do 0 minus negative 0.4, because I'm subtracting the y's and putting that over the subtracted x's. So then that would be 2 minus 0. Minus and minus is adding. So then the slope should be 0.4 over 2. Or that's also like 4/10 divided by 2, which is the same thing as multiplying by 1/2. So then that goes into 2 goes into 2 one time. It goes into 4 2 times. So it would be 2/10, which is also 1/5. So we know that our slope is 1/5. So if we're thinking y, and then I'm not putting equals because it could be like greater than or less than in that portion, not equals. Y is greater than or less than mx plus b, that same formula. We know that the m has to be 1/5. So 1/5 x, and then our y-intercept is going to be negative 0.4. So negative 0.4 as a fraction is going to be negative, that's negative 4/10. That's why they call it 4/10. So negative 4 over 10, and then if we simplify that by dividing by 2 on top and bottom, we're going to get negative 2/5. So that means we have to have plus negative 2/5, which is the same thing as just minus 2/5. So already we can say, okay, it's definitely not A. It can be either B or D now, because they both have, these are basically the same thing. I just wrote them differently to be extra annoying. So like 1/5 x, if you just multiply it by x over 1, turns into this, the same exact thing. Now we just have to decide, okay, is y going to be less than or greater than? So the way that you can figure this out is by looking at where the shading is for this. So the shading is above the line. So since it's above the line, y is going to be greater than the line. So then like the possible y values that it could be are greater than the line that's been graphed, or the dashed line, I guess, that's been graphed. So it has to be D. But it's literally the same thing as y equals mx plus b, except like the dotted line thing, and then like where the shading is with your inequality symbol. So then let's go to number 25. This is one that they're really seeming to like on the digital exam. I kept a lot of like my same problems for the previous SAT, except I kind of like changed some of the wording sometimes if I felt like it was beneficial, unless it made the problem like significantly easier. But like this was one of the ones that I added specifically to this book to correspond with problems that are showing up repeatedly on the digital SAT exam based off of the study guide. So this would be one to pay attention to. I'll explain number 24 after, yes. So we have this system right here, and it's saying if the point x comma 64 is the solution to the system of inequalities above, then which of the following is a possible value of x? So remember, this is x comma y. Like our points are just x comma y. So that means y is 64 is what they've essentially told us. So let's plug that into the top one, and let's say 5x plus 64 for y is going to be less than 26. Now we're trying to solve for x, right? So we have to just subtract 64 on each side. So then we get 5x is less than, and then minus 64, that's going to be, is that 38? Minus 38? Yeah. Wait, hold on. I think I did that in my head wrong. I can't do things in my head. The numbers get all flippy. Hold on. Oh, wait, I did it right. Okay, so negative 38. So it's going to be 5x is less than negative 38. So then we divide by 5 on each side. So we get negative 38 over 5. So just like with one of the problems I did a little bit before, you can kind of like estimate the like what this would be between, like what integers it would be between. So we know 5 times 7, or 5 times negative 7 gives us negative 35, and 5 times negative 8 would give us 40. So this is between negative 7 to negative 8. Like, it's a value in between that. So x has to be basically less than that decimal value that would be between negative 7 and negative 8. So let's see what fits that criteria. Well, that would just be A, negative 8, because negative 8 is a value that's less than something that would be somewhere between like negative 7 and negative 8. You could do the exact calculation if you wanted to as well, but I mean, this is kind of just how I do it. Okay, so I think that was it. Yeah. Okay, so someone wanted me to explain number 24. Let me get rid of this so it's not like confusing. So you said, can you explain number 24 again? Yeah, so basically with number 24, it's just, finding the inequality that matches the graph. So all you have to do is, like, it's the same thing as when you learned y equals mx plus b, except instead of an equal sign, it's just greater than or less than. So you follow the same, like, the same steps that you would to graph y equals mx plus b. It's just that you have to be careful it's not an equal sign anymore. So we have 2 points that are on this dotted line, so we could use those 2 points, plug them into the slope formula, and then find out the slope, which we found out was 1/5, positive 1/5 once we plugged it in. So then that becomes your, that becomes your slope, or your m. So 1/5 went there. And then we said, okay, now let's find the b, the y-intercept, the starting value, however you refer to it. Well, that's going to be negative 0.4, which as a fraction is just negative 2/5. So then all you have to do now is, well, you could say I'm just left with choosing between b and d, because those are the ones that match the dotted line equation that I've just come up with. And also, we eliminated C earlier because since it's a dotted line, you can't have that little line underneath, is one of the rules that's different about inequalities. So then we said, okay, we have to determine is it B or D? And the way to do that is to look at the shading now to determine if it's greater than or less than. And it's shaded above the line, so that means that Y has to be greater than that dotted line. So that's how we figured that one out. Okay, now I'm going to answer any questions you guys have that you want to put in the comments about. I usually answer any questions about like this stuff, digital SAT, ACT stuff, college consulting stuff as well, or just like stuff in general about high school, I guess, like high school stuff, except for science. I'm like not good at science unless I can prepare. But yeah, put any questions you have in the comments. I'm probably going to come back and do another live at some point tonight because I have a lot of videos to record. So I would just like keep an eye out on my page. It'll probably be like maybe around 8 o'clock, but don't quote me on that. Okay, thank you very much. I believe I was confused on the last part, but perfectly got it now. Okay, awesome. Anybody have any questions before I head out? And when I say 8 p.m. probably, I mean like it's probably around 8 p.m. Eastern time I'll do it. But again, don't quote me on that. Okay, don't see us getting any question. Okay. What resources do you recommend studying for the math section of the SAT? I mean, I'm a little biased, but I wrote my book specifically for my students. That's why it says AG Tutoring LLC. Because I think that the other resources I thought that the other resources could be improved upon. So that's why I wrote this. So if you go to my website, you'll be able to download this if you like. But in terms of like other resources, I would say, like, for free, Khan Academy, because they're official partners with the College Board, is a great resource. And then also the College Board, like the official practice test, because you always want to be practicing with official stuff. So that's another thing that you want to look out for. And the College Board, like, you don't have to buy the study guide either with the tests. They upload them for free on their website. Anybody else have any other questions? Is your website in your bio? Yes, it is. I like wrote it down in my bio. It's also linked, but for some reason some profiles can't see it. But it's just AG, like A as in apple, G as in like goblin, hyphen tutoring.com. That's it. Anybody else have any other questions? And some of these chapters I also release for free on TPT. So like you could buy like the whole book for, I think it's like $20. Or like you could buy just individual chapters that like you want to review, or some of the chapters, like I said, I've released for free. So like you could download those for free too. And I have a bunch of other free resources too. I like try to upload several free resources on there a month. Thanks, guys, for the likes. Well, it looks like we're not getting any other questions, so I'll be back in probably about an hour. So I will see you guys then. Bye, guys.